Hi, my name is Mia, and for my STEMinista project, I built me and my mentor, we built a little model car, and we used air pressure to move it forward, and then we used math formulas to measure the distance, and then we changed the distance using the formulas to what the volume of the air was, and the circumference of the balloon and the radius. So in this project, we wanted to see if we could measure how far a car would go with different amounts of air volume. Here's the car. So in my next slide here, we have the materials for it. The cardboard is just what we use for the base, and then there's a balloon that you blow up. And then the tape is just used to hold everything together. We cut up a pen to use it so that we could blow air into the balloon. The wheels are here and they're glued on. And then the skewers are in the straws on the bottom so that the wheels can move like that. So the steps that we used were we built the car, and then we blew up the balloon after we built it. Then we measured the circumference using just like a tape measure, and then we propelled the car, and then we measured the distance and we recorded the data, and we did this about 7 times. So some of the trial and errors that we did were for our first car, we noticed that the platform was too small. So the balloon was hanging off the back of the car, which messed up our data a lot because the car wasn't going anywhere. And then the car eventually started swerving off to the side. So we realized that the wheels weren't on straight, so we had to fix that. And we tried to measure the volume with water for the balloon, but we realized that wasn't going to work, so we figured out a formula for it. So here is a video link of it going. So yeah, that's basically what it was. And then so our next slide. Okay. Next, here's the graph that we used for the circumference versus the distance. We used a formula to change the distance to the circumference. And then here's the distance to the radius. The formula for here is the circumference equals pi r times 2. R is the radius, and then and then for this one, it was 4/3 pi r cubed, and that was to find the volume versus the distance. And then here's the data that we pulled up just before we put it into the graphs. And so then here's kind of what we did. We blew up the balloon. And then basically we just let it fly like this, and it moves forward like that. But so that's kind of how it would work if we were doing it like at the real time. And then from doing this project, I've learned that the larger the circumference is, the larger the distance, the volume, and the radius is. We showed that the higher the volume, the more air was in the balloon, and the more there was to push the car. Also, the formula for the volume cubes the radius. Therefore, small changes in the radius leads to a big change in the volume. Thank you.